right, but as Yolanda said, today we're talking about fractions, and we're going to just chat about some basics to start off with. So we're going to get to things like cross-canceling and multiplying and tip and times and LCD. But if you haven't heard any of those things, don't worry, we're going to do them. But for now, we're just going to start with some basic knowledge, concepts that have to do with fractions. Alrighty, so a fraction is basically a way of representing parts of a whole. So I'm going to put that here for us. And a fraction is made up of two parts. Now, those two parts of our fraction are the numerator, which is the top number, and you can see this down here. So the numerator is the number right at the top of your fraction, and a denominator, which is the number at the bottom of your fraction. So a fraction is made up of two parts, a numerator and a denominator, and it tells us, or it allows us to represent parts of a whole. Now, what do I mean when I say that? So let's have a look at an example. If I have a look at this fraction, a quarter, it is essentially saying to me that I'm working with one part out of four parts. And we can see that in our picture here. We can see in our square, we've got 4 blocks going on here. So that represents my denominator. And we can see that only one of those blocks is shaded in, hence the 1 out of 4. So my whole, whatever that may be, is split into 4 parts, and I'm only considering one of those 4 parts. And this is why a fraction allows us to represent parts of a whole. All right, so again, numerator and denominator make up a fraction, and fractions allow us to represent parts of a whole. If you want to take a screenshot, quickly do that before we move on. But what we're going to have a look at next are the different types of fractions that we can work with. And then we're going to start working with these fractions and understanding how we use them, why they're important, so that it leads us up into our next couple lessons of fractions. Okay, so you're taking a screenshot. And remember, guys, if at any point you have any questions, please post them on the chat. I will ask for hands if there are questions, but please don't raise your hand until I ask. Right, and then obviously, guys, we completely understand that load shedding, especially now we're at stage 6, there's network issues, data issues, no electricity issues. So like, please don't stress, everything's recorded. You can grab it on the website within 24 hours. Okay, we completely understand that that is the reality we're facing at the moment. Alrighty, so let's have a look at some different types of fractions that we'll work with. Now, you have your basic common fraction, which is just sort of like what we had here, a quarter, but we have other types of fractions that we need to be able to work with. So the first one is a mixed number. Now, mixed numbers essentially have, much like a fraction, 2 parts to them. So the first part of our fraction is the integer or the whole number part. Okay, now I'm saying integer just because sometimes that whole number can be negative. So it's just important to remember that. But basically, there's a whole number in front of, or as my first part of my mixed number. The second part of my mixed number is then the fraction portion. And what this is essentially allowing me to do by working with the mixed number is it allows me to represent more than one whole or 2 wholes, etc., and then parts of another. So if we think about this as a picture, now my pictures are not going to be beautiful, but it's all right. We've got 2 wholes and 1/5. So I'm choosing to work with rectangles just because it's a little bit easier, but you could really draw any picture you wanted. And I'm choosing, or I am dividing these into 5 parts because my denominator tells me I'm working with 5 parts of the whole. So if we then think about the integer or the whole number part of this mixed number, 2 wholes mean that I am working with complete rectangles. So there's my 1, and then there is my 2. So there are my 2 wholes. When I then come to the fraction portion, it's saying I'm only considering 1 part out of 5. So I'm only shading in 1 block. All right, so excuse me. A mixed number allows us to work with more than a whole or more than multiple wholes and then part of the next whole. Now, you can draw pictures if you want. If it helps you understand it better, that's absolutely fine, obviously. But we are going to chat about how to convert between mixed numbers and improper fractions and vice versa as we get into the lesson. So don't stress about that. But basically, we're working with 2 wholes and then part of the third. In this case, only 1 part of the 5 that make up the third whole. Righty, improper fractions then. Improper fractions and mixed numbers sort of work hand in hand. Improper fractions is when your numerator is bigger than your denominator. So your top number is bigger than the bottom number. Don't leave myself much space for this, but anywho. So what you can see in the example is exactly that. You can see that we've got a numerator of 7, a denominator of 2. My numerator is bigger than my denominator. Hence, it is an improper fraction. Now, like I say, improper fractions and mixed numbers work hand in hand. We can convert between the 2 formats, and we're going to talk about how to do that now. But essentially, an improper fraction does exactly the same thing as a mixed number. We just write the information slightly differently. So if we think about the 7 over 2, we're talking about 7 parts of wholes that have been split into 2. That's what those numbers talk about. So here are my 7 parts, these sort of half moon things. It would help if I could count. They are the 7 parts, which is my numerator. And the 2 is telling me that I'm splitting them in half. So that's why I've only got half a circle for each of my shapes. The denominator is 2, so I'm working with half of my shape. Which means that now when I combine all of my shapes together, if I match up half circles and half circles, I get 3 wholes, hence my whole number 3 over there. And then I've got 1 half circle remaining, just this one little half circle. And so hence the fraction part of my mixed number, 3.5. Now again, diagrams are great, or pictures are great if you need them, and you're always more than welcome to use them. But just understand that an improper fraction tells us the same information as a mixed number. We're just writing that information in a different format. Right, if you don't like the pictures, that's fine. You don't, like I say, you don't have to use the pictures. I'm just trying to help those people who do understand things a bit better visually to work with them. We're not going to work with pictures all the time. I'm just trying to give everyone the best chance to be able to understand what's going on here. So take your screenshots if you need them, and then we're going to have a look at some examples of how we can start working with these fractions. Right, screenshots, it depends what device you're using. On a computer, you can say print screen, and then you just need to copy it over to a document. Otherwise, grab your cell phone and take photos of the screen as we go along. Remember, guys, any network issues, everything is recorded, so you can get the recording tomorrow. So it comes out within 24 hours.
Yep, guys, no problem at all. Do not worry. Okay, my people. Let's keep it rolling. My peps will do this.
Okay, I'm hoping you've all got your screenshots. I'm about to scroll down. Right, so let's actually start working with these fractions. Now, one of the most important things when we start working with operations as fractions is understanding what a fraction is actually telling me. And in order to do this, we need to understand that sometimes fractions might look different, but they represent the same thing. And this is what we call equivalent fractions. Equivalent, equal, they are equal fractions. They represent the same thing. So If we have a look at our example here, we've got 2 over 5 is equal to 4 over 10. Now, again, you don't have to like the pictures. It's absolutely fine. I'm just going to try and help everyone understand here. If I can draw some pictures. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Got there in the end. So if we think about, I'm going to sneeze. Oh, sorry, everyone. Excuse me. Okay, so if we think about our two fractions here, we've got a fraction of 2/5. So if we go to my bottom rectangle, I'm talking about 2 parts out of 5. And if we then go to our second fraction, we're talking about 4/10. So I'm talking about 4 parts out of 10 parts. And what we need to see here is that these rectangles are exactly the same length. So they're exactly the same size. And the shaded regions take up exactly the same amount of space in each. And so this is what an equivalent fraction is. It's fractions that look different, but represent the same part of the whole. Now, again, if you don't like the pictures, don't work with the pictures. That's absolutely fine. All right, so I just made that a bit shorter, otherwise it gets a bit wordy. So equivalent fractions are fractions that look a little bit different from each other, but they actually represent the same amount. So Zintle, there is your definition. I've written it down for you. And so what we need to be able to do is work between fractions and different forms of the same fraction, essentially. So if we think about the pizzas shown below, as you can see in all of the pizzas, the same amount is shaded. So when I say shaded, I'm talking about the gray pieces. In the first, my pen's just being difficult. In the first picture, I've got half my pizza shaded, hence the fraction. In my second pizza, I've got 2 of my 4 pieces shaded, hence my fraction. And so we can keep going. I've got 4 of my 8 pieces shaded. I've got 8 of my 16 pieces shaded. But hopefully what we're seeing is that each time I'm actually talking about half of the pizza. If we look at the shaded region, it's half of the circle. Yes, the circles are cut into different amounts or different slices, but it represents the same amount. And so all of these images or all of these fractions represent half of my pizza. So a half, 2 over 4, 4 over 8, 8 over 16 represent exactly the same thing. And this is what our definition says equivalent fractions are. Fractions that look different, they have different numbers at the numerator and denominator, but they represent the same amount. All of these pictures with my pizza represent the same amount of pizza. I'm eating half of the pizza. It just depends how many slices my pizza is cut up into. Right, so that is essentially an equivalent fraction. Fractions that represent the same amount. We are going to learn about adding fractions, not yet, but we are going to chat about it, I think, on Wednesday, if I remember my own schedule correctly. Right, so guys, take a screenshot of this if you want, and then we're going to have a look at some equivalent fraction examples. Righty, I'm hoping we've got our screenshots. Quick. Right, so let's have a look at some examples. If we have a look at our first example here, we want to fill in the missing numbers. Now, basically what that means is I want to fill in the numbers either in the numerator or the denominator that make these fractions equivalent. How do I know that's what I'm doing? Well, because there's this equal sign. It's telling me that this fraction is equal to this fraction is equal to this fraction. they all have to represent the same parts of the whole. Now, again, the pictures are great if your fraction's denominator is quite small, all right? But if not, then we've got a little bit of a problem. So we need to be able to do this without having to draw huge pictures with like 40 parts, etc., etc. And so what we do is we now look at our fractions and we decide how can we manipulate one fraction to represent the same amount. So when I say manipulate, this is what I mean. If I look at my first fraction, it represents 4 parts out of 5. My second fraction has a denominator of 15. So I have to ask myself, what am I doing to 5 to get to 15? Well, if I times 5 by 3, I get 15. I then do exactly the same thing in my numerator. Remember, I wanted to represent the same thing as 4 over 5. So what I multiply my denominator by, I need to multiply my numerator by. And so if I multiply 4 by 3, I end up with an equivalent fraction of 12 over 15. Right now, when typing this on your calculator, just so that you can see your calculator does do this for you. If I type 12 over 15 on my calculator and I push equals, it gives me 4 over 5. So it gives me that same equivalent fraction that we started with, 4 over 5. Right, so if we then have a look at the next fraction, we need to use the same logic, but now it's in my numerator. So what am I multiplying 4 by to get 24? Well, I know if I say 4 times 6, I get 24. So I must do the same thing in my denominator. I must say 5 times 6, and that will give me 30. Now again, if I type 24 over 30 on my calculator and I push equals, it gives me 4 over 5. And so it's representing exactly the same portion as the rest of my fractions. So 12 over 15 and 24 over 30 still represent 4 out of 5 parts. And we can sort of see this because we can now tell that these fractions are not simplified. 12 over 15 and 24 over 30 are not simplified. If I simplify them, I would get 4 over 5. So they represent the same amount. Alrighty, so at this point, I'm going to ask that you try question B. If you are struggling, please raise your hand to ask a question or type it in the chat so that we can help you. But now, right now, you are either trying question B or you are raising your hand to ask me a question. Grade 8s, please can we also focus on the chat? Whatever anyone else is doing, you don't need to stress about. You need to focus on question B. If you have questions, like I say, you need to raise your hand. Rato, equivalent fraction. Basically, we're saying that fractions that look different. So we can see that all of these fractions here look different. We've got a 4 over 5. We've got a 12 over 15. We've got a 24 over 30. Even though they look different, they represent the same parts of the whole. I could attempt to draw a picture. It's just going to be very tedious. But basically, if we make some attempt here. So 4 out of 5, if I split my rectangle into 5 parts, there we go. We're talking about 4 parts out of the 5. If I then go 12 to 15, I would have to split each of these blocks into 3 to get my 15 blocks. But look, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 parts shaded, hence 12 over 15. If I wanted to then get 30 parts, which is going to be a little bit of a mission, I would have to split this into half again. So I've got all these tiny little thin rectangles that I'm talking about. But if I count them, which again, very tedious, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Sorry, I got a bit squished there. We've got our 24 over 30. So all of them represent exactly the same parts of the whole. As you can see here, my shading didn't change. I'm still talking about the same amount of my rectangle. I can just represent that portion of my rectangle using different fractions. Right, what I did forget, if you're struggling to write down your answers on the chat, let's put an X here and put a Y. So you're looking for the values of X and Y. Immediately, I will show you how to do the, I'll show you how to check on your calculator now in a second. Okay, Lorato, I'm hoping that my explanation has helped. I did just explain, hopefully, the question that you asked, so hopefully that's helped. Good, well, I'm not too sure what you're saying no to, but I'm hoping we're all focused. Elitle, well done. Guys, please remember, I haven't asked for hands yet, so please don't raise your hand yet. I will tell you when I want hands.
Let's go, my people. Remember, you are writing it down first on your book, and then you are putting it on the chart. Like this, we can do corrections, okay? Because it doesn't mean that whatever you put here is correct until Teacher Sam talks to us and tell us the correction. You guys are doing really well. And please, because we are so many of us, do you see? So on the charts, there's no thing of chatting about anything that it's not what Teacher Sam is asking, okay, my people? Let's go. You are doing really, really well. If you can please label X equals 2 and then give an answer. Y equals 2 and give an answer so we can understand. At this moment, I just see random numbers and I don't understand it. Google it too. Thank you so much. This is what we want to see, okay?
Yo, guys, sorry, I forgot to put in my X and Y's. That is completely my fault. I should have put it in.
Google it too. Thank you. And Motibang, I'm so happy that it's easy for you, but please put the answers there, okay?
Alrighty, guys, so I see lots of answers coming through, which is awesome. At this point, if someone would like to raise their hand to give me the answer for X, and then we'll do an answer for Y from someone else. Okay, Didintle, do you want to give me X first?
Ma'am, X, I got 96, ma'am. I said
Excellent.
8 times 12, ma'am.
Excellent. So guys, we know that 7 times 12 gives us 84. And as I said, we do exactly the same thing with the denominator. So 8 times 12 gives me 96. Very well done.
Ooh, well done, Teacher Sam. Teacher Sam,
yeah.
Sorry, I just saw an excited student, Elena, who wants to answer. Sisanda, can we please unmute Sisanda, please, so Sisanda can answer.
Teacher Sam.
Okay, Sisanda, you there?
Teacher Sam.
Yes, ma'am.
Okay, tell me.
The answer to Y?
To Y. Tell me the answer to Y.
It's 32.
Okay, how did you get 32? Help me out. What was your method?
So, ma'am, you see, from 8 to 96, that got to 2 times 12. I saw that you should what's this, minus 56 from the number that's like from 84 minus 56, which got me to the answer to 32.
Okay, so I like your thinking. I like that we're looking at our values and actually trying to work with them. So very well done. Remember, we want to try not add or subtract. We always want to try and multiply. So what we can do is we can look at 8 and how did we get to 40? So if I times 8 by 5, I'll get 40. And so I then can do the same thing in my numerator. If we start adding and subtracting, we're starting to change what the fraction is saying to us. So Y is 35, but very nicely done. And I'm glad you're actually looking at the relationships between these numbers, guys. That is the whole point here. We want to be looking at the relationships between our numbers.
She was so excited. I'm so happy for you, Sisanda, and hopefully that you now get it. Well done, Sisanda.
Alrighty, guys. So also just a reminder, once you have answered a question or asked a question, please remember to lower your hand and mute yourself, okay? And remember that the chat is there for you to ask questions as well, so use the chat function. So everyone whose hands are up, you can lower them. I'm going to ask for questions now. So if anyone has any questions, please raise your hand. Now is the time to do so. Njabulo, what is your question? Okay. Didn't question?
Ma'am, for why, ma'am, I don't understand them, ma'am. Because I got X right, ma'am, but then why I didn't understand what's going on there, ma'am.
Okay, so for y, what we want to do is we want to go back to our original fraction, so that's 7/8, and we want to see how I got from the denominator of 8 to the denominator of 40. Now, 8
Yes, ma'am.
times 5 gives me 40. So I'm going to do the same operation in my numerator, 7 times 5, and that will give me 35/40. Now, if I do that on the calculator, so 35/4, I can't see my own face, which is a little bit unhelpful. So if I type 35/40 on my calculator and I push answer, I get 7/8. And so this is my check. So those of you asking for the check on the calculator, if you type it in and you get the same original fraction, so I got 7/8, that was my original fraction. Because I'm getting the same thing, I know that I've done it correctly.
Oh, okay, ma'am, I understand, ma'am.
Good, well done.
Thank you.
Oh, okay, I'm just clicking things, you can ignore me. Jabulo, do you have a question for us?
Yes, ma'am. My answer say 48 and 21.
Okay, how did you get those?
I said 7 multiplied by 3, I get 48. And 8 multiplied by 40, I get 21.
Okay, so just be careful. We're not working with 48, we're working with 84. So you've swapped the numbers around.
To all the answers.
Yeah, so just be careful, you've misread. It's not 48, it's 84. So you swapped the numbers around. So you had to see 7 times what gives you 84, not 48.
Yes, ma'am, I understand now.
Okay, good, well done. Right, Apulele, question?
Ma'am, is it okay if I said 40 divided by 8, then I got the answer 5, then I said 7 times 5 equals 35. Is it okay?
Absolutely, perfect.
Yes, ma'am.
Okay, on Karabile, question? On Karabile, you there? There we go.
Ma'am, I can hear, but I can't understand.
Okay, so are you not understanding the maths or is the sound funny?
In the maths.
Okay, so just remember everything is recorded. So if you're struggling to hear, you can get the recording on the website, okay? So we are
Okay.
going to do more examples.
Okay, ma'am.
Right, now once again, grade 8, your chat etiquette is questionable. You are focused on maths and maths alone. If you are going to be disruptive, rude, or just not appropriate, I'm going to remove you from the lesson. It's quite simple. So those of you being inappropriate right now, stop. Otherwise, I am going to remove you. We're focusing on maths. Right. Let's take a brain break. Hopefully this will refocus some of you. For those of you that are new, a brain break is basically just a little break in the lesson that we take before we carry on with more examples. It's just a chance for you also to get up, stretch, go to the bathroom if you need to go to the bathroom, try something a little bit different. But all of these brain breaks, especially these ones that I do with like the find the value of the picture. They really help you with your number sense. They really help you when you start solving equations, which we're going to get to later on in the year. And so trying to do this practice is very important. So what we're going to try, hopefully we can get it, is I'm going to make the brain break bigger in a second. I want you guys to try and get the final answer for me. So where this question mark is, that equation, I want you guys to try and figure out what that answer is. The only thing I am going to say is just be careful. Some of the pictures have two. So there's two turtles, but there's only one turtle. So just be careful of that when you're trying to do your working out. The first correct answer that we see on the chat, we will call your name and you can hopefully explain it to us. You don't have to find the jokes funny. They're just there as a little something. You enjoy it, you don't enjoy it. Really, whatever. On Karabile, if the network is giving you a problem, don't stress about the brain break. Use the time to get up and stretch and move a little bit, and we will carry on with the maths now in a second. Some of you don't see the joke just because I have made the screen bigger, because I want you to be able to see the brain break. So if we feel we need to see the joke, let's do this. And let's make the screen bigger. All right, so guys, first correct answer that we see on the chat. Deborah, please do use BODMAS. It's a very, very good point. BODMAS is very important here, guys. All righty, so BODMAS, see if you can find for me the value of that last equation. That's a turtle, tortoise. I don't really mind what you choose to use. Turtle's probably easier to spell.
Guys, let's go. Remember, we need to find the final answer over there, okay? The final answer with the question mark, that's what we're trying to find. Okay. So let's go. I'll let you know if you get it right. So we want the final answer, and I will let you know if you get the final answer correct. So I'm not going to give you any clues. We all need to figure it out, okay? But remember that we want a final answer. That's what I'm looking for. So let's keep them coming. I see Tulani is focused on your book over there. Apelele, I hope that you are trying to work it out. Let's go, my people. It's not 85. I'm not gonna tell you any details. We want the final answer, but definitely it's not 85. Let's go. I'm not gonna give any hints. It's not 65. Let's go, my people. Guguletu is definitely not that number either. Let's see, I wanna see the winner of tonight's quiz. It's none of those numbers that you've given me now. Nope. Ooh, Rina, you was too close. Nope. None of those answers are correct. Nope. Ooh, hey, Mona, you're also too close. ML, you are also too close to an answer, but it's not that one. And nope. We haven't seen an answer yet. Nope. Whoa, that one was so close. So close. Guys, are we just guessing numbers now? Because we will stop this game and you guys are gonna have the same brain break on Wednesday until you figure out the correct number. Because I see now you're trying guess game here. Okay, my people. Oh, someone got it. Whoa, but if you got it, you need to be able to explain. If you can't explain it, it's also wrong. So Tuso Shengshe, hopefully I'm pronouncing it well. if you got that answer, please raise your hand because you got the correct answer. I'm not going to say what it is. Raise your hand so you can explain to us why you got that answer. How did you get that answer? Come on. Let's go. Raise the hand.
Let's hear it.
Yeah. If not, I'll choose someone else. If anyone got a correct answer, I'll just choose them. But Tuso, please help us out. Let us know, how did you get to that number? Okay, if I see someone else, I'll definitely call them. But Tuso got the correct answer. Let's go, my people. There we go. Tuso, so I'm giving your number away, or your state, your Okay, Mpilinhle, please raise your hand so you can talk to us. How did you arrive to that answer? There we go, Mpilinhle. You can unmute on your side.
Afternoon, ma'am.
Hi.
Ma'am, how I found the answer is that I calculated how much the turtles were, and it was 4. And then the lobster, I think it's a lobster though, it was 5. And then the fish was 6. So I said 12 plus 5 times 8 is equals to 52.
Okay, good. Oh,
bravo, well done.
Something in my eye now. Okay, so guys, just so we're all clear on how Mpilinhle got all of those. So you're adding 2 turtles each time, or tortoises, or whatever they are. So 8 plus 8 plus 8 gives me 24, which is why 1 turtle is only 4. So here in the second row, I've said 4 for 1 turtle. Now, remember BODMAS, I think it was Deborah who pointed out BODMAS is very important. So we do the times first. 4 times 5 is 20. And then 20 plus 4 gives me the 24 that I want. So BODMAS is super important. Then 1 lobster is worth 5. So 2 lobsters is 10. And then we've got 12 times 12, which gives us 144. So again, BODMAS first, do the multiplication first. 144 plus 10 gives me the 154 that I want. And so 2 fishes, which is 12, plus 1 lobster, which is 5, times 2 turtles, which is 8. We can get our final answer. Again, do BODMAS. So 5 times 8 is 40. 40 plus 12 is 52. All right. Very,
well
very nicely done.
Yeah. Did really well.
Okay. So guys, if you've never done one of these before, that's essentially how you do a brain break. I do a lot of these because I think they're fun, but they also mathematically help you. Like, this really, really helps you just with number sense, with solving equations, understanding your operations. So if you give them a try, hopefully you will just become better with practice. Right, Zintle, I see your hand is up. What is the problem?
Ma'am, is it fine since I don't see the animals clearly? So for the second row, is it fine since I thought it was still like as in 2 of the turtles? So I wrote 8 times 2 plus 8, which still gave me 24.
Yeah, so your numbers there are then absolutely correct. So your values might be a bit different, but that is fine. Yeah, I did try and make it as big as I could, but I will try and make the pictures a little bit clearer next time. Thank you, Zintle.
Thank you.
Alrighty, guys, so let's carry on with some fraction work. Brain breaks happen every lesson, otherwise an hour to sit for an hour doing maths is quite a long time. So brain breaks do happen every lesson. If you don't understand the brain break, don't stress. It's just something to try. It's not part of the actual work. It's just a break taken. We do something different. Alrighty, so what I want to have a look at here is converting fractions. So converting between mixed numbers and improper fractions. Now, again, like, the pictures are great to understand what's going on, but to draw a picture every time becomes a little bit tedious, and you'll see what I mean now in a second. we need to find a way to convert these fractions quicker so that we're not wasting time in a test or in an exam or in an assessment. Excuse me. So if we think about what our mixed numbers saying to us, we've got 4 2/3. So if, and again, you don't have to like the pictures, it's absolutely fine. If we do the pictures and we try and understand what this mixed number is actually saying to us, we've got 4 holes. So here they are, they're coming very slowly but surely. And then we've got 2/3. So we've got 2 of the 3 parts of my 5th hole. That's essentially what it means. Now, if we consider the blocks, and the reason I've got 3 parts here, or I'm about to have 3 parts, is because my denominator is 3. So it's telling me each of the holes are split into 3 equal parts. The 4 holes, so the whole number part of my mixed number, is sort of an entire rectangle shaded, and there's 4 of them because of that whole number in front. And then my fraction part that I'm working with is in 2/3. So 2 of the 3 blocks are shaded in. Now, in order to get an improper fraction, what we do is we count how many shaded blocks we have. So this would be 3, 6, 9, 12, 13, 14. So I've got 14 blocks shaded in, and we always use the original denominator, so 14 over 3. And now I've got, exactly as Maduna said there on the chat, my improper fraction. But that's so time consuming. I don't want to draw all these rectangles and color in and all the rest of it. So we need to find a different way to do it. So the way that we do that is essentially through this little method. We take the denominator and we times it by the whole number. So we say 3 times 4, because there are our whole numbers, and there's 4 whole numbers or 4 whole groups, and each of them are made up of 3 parts. So we say 4 times 3, which we know is 12. And then we add the 2 extra blocks. So the 2 parts that don't quite make up a whole, we add. So we would say 12 plus 2. And that gives me 14. And hopefully you remember that my numerator was 14 over 3. So my improper fraction I can find by timesing the denominator by the whole number and then adding the numerator. So that is a quicker way to go about converting your improper fractions. Again, your calculator can do it, but you need to know how to do it by hand and show you're working out. So again, times the denominator by the whole number and then add your numerator. Right, but we also need to be able to go the other way. So we also need to be able to go from an improper fraction to a mixed number. Now, again, there's lots of different ways you can think about this. I don't know, my words just escaped me. So if we think about the denominator of 6, essentially what that's saying is I'm working with 6 parts and I've got 22 of them. I don't particularly want to have to draw all of those. So just imagine it of you are working with 6 parts, 2, 3, 4, 5, there we go, 6. And we've colored in 22 blocks. So there's going to be quite a few of these little pictures that I've got going on. But like I say, this is time consuming. We don't want to waste time. So how else can we do this? What I like to do is I like to think about my denominator and its multiples. So 6, 12, 18, 24, and so on. Because what this is saying to me is that 22 is being divided by 6. So I want to figure out how many times 6 can go into 22. And if I know the multiples of 6, that makes it a bit easier. Now 22, the number 22, that numerator, is sitting somewhere between 18 and 24. It's not a multiple of 6, so that's why it doesn't divide in perfectly, but it's somewhere between there. So now I can go and say, okay, well, I definitely have 3 holes because I've got the first 3 multiples of 6 in the 22. Not making up completely 22, but I've got them. So my whole number is 3. Then I need to ask myself, I need to go from 22, oh man, I keep doing it the wrong way. I need to go from 18, which is my 3rd multiple, to 22. What am I adding to get there? Well, 18 plus 4 gives me 22. So 4 parts out of 6. If I add that, I will get my fraction. Now let's just see why that's the case. If we use our trick, 6 times 3 is 18. And then if I add my numerator, so 18 plus 4, I get 22. And so we have an improper fraction of 22 over 6, which is what I originally had. Right, so you can also think of it as, like Lorata said there on the chat, 6 times 3 gives me 18. And then if I add the extra 4, I've got my 22. You can really think of it however you are comfortable with. But I like to think of it, how many whole 6s can I fit into 22? And what do I then have left over? Now, guys, remember, you always need to work with simplified fractions. So this 4 over 6 we can simplify. I know I'm a bit all over the place here, but this can simplify to 3 2/3. Reason being is because I can divide 2 into both 4 and 6. 4 divided by 2 is 2. 6 divided by 2 is 3. Right, so improper to mixed numbers, I find a little bit harder because of the division, but just think about how many times you can get the whole denominator into the numerator and then what is left over, because generally it won't be a perfect division. You will have some remainder that you then need to work with. Alrighty, so take your screenshots. While everyone's taking a screenshot, if there is anyone with a question, now is the time to raise your hand and ask. Retabile?
Ma'am, can you take off where you circled 18 with the green thing, green color? I don't understand from there.
Okay, so when I circled the 18, what I saw was that 18 divided by 6 is 3. I get a perfect whole number. And the number I'm looking to try and divide 6 into is actually 22. Now, 22 is not a multiple of 6. 22 is somewhere between 18 and 24, but it's not a multiple of 6. So I go to the multiple before the 18 and I say, cool, I definitely can get 3 whole 6s into 22, but I can't get 4. It's not quite 4. So how many do I have left over? What parts of the whole do I have left over? So if I'm currently sitting at 18 and I want to get to 22, how many parts do I need to add? Well, I need to add 4 parts, hence my fraction 4 over 6. So the 18 is telling me that I definitely have 3 whole 6s I can get into 22, but then I still need to figure out what my remainder is when I do that division. Okay, I'm hoping that makes sense. Don't see your hand anymore, so let's hope so. Zamo, question?
Ma'am, if you simplify 3 and 4 over 6, and then you get 3 and 2 over 3, if you change it into a mix, into an improper fraction, are you still going to get the same answer?
Yes, it's still correct because this original fraction, so 22, oh golly, it's not gonna work. So this original fraction of 22 over 6 can actually be simplified. I can divide both of those by 2 and I would get 11 over 3. If we then take this 3 and 2/3, 3 times 3 is 9 plus 2 is 11. So I get 11 over 3 as well. So it's fine that you've simplified, you do end up with the same thing. Good question, well done. Ayanda, question? There should be a pop-up to unmute.
Ma'am, my question is not based in here.
Ayanda, I can't quite hear you.
Ma'am, my question is not based in here, but I got a problem.
Okay, so remember we're focusing on fractions right now. That is what our lesson is about for tonight.
Okay.
Okay, guys.
I need
what you will see is that there's a poll up there. Please make sure you do answer the poll. I understand you're cutting out. I can't quite hear you. I don't know what's happening. But remember, any questions that you have based on homework or other work, if you join the lesson a little bit earlier, we'll help you then, okay? If that's what you were trying to ask. Katlelo, do you have a question? Katlelo, sorry.
Yes, ma'am. Ma'am,
Yes.
I do have a problem with 4/6 divided by 2. How did you divide 2 to your fraction?
So the 4/6 I can simplify. 4/6 is a fraction that I can simplify. So if I divide both the 4 and the 6 by 2, I can simplify the fraction, and I always want my answer to be as simple as possible.
Yes, ma'am. Thank you.